Good morning, students, and Happy New Year to everyone. In the last class, I have started the chapter probability and defined what is experiment and the sample space corresponding to an experiment and event and type of events. Okay. Now today we will define the probability. Okay. What is probability or axiomatic definition of probability? Okay, let A be an event corresponding to a random experiment E whose sample space is S. Now whenever we find a experiment, the S sample space contains all the possible outcome of that experiment. So let number of S means number of element or number of outcomes in this set be n. Okay, now let A be an event for which we have to find the probability. So the probability of A is defined by this symbol P of A, and the formula for which to find the probability of A is the number of favorable event corresponding to A divided by the number of total outcome, which is the number of element in the set S. So number of element in the set A divided by number of element in the set S. Let's say number of element in the set A is M. So by definition this will be M by N. M is the total number of outcome favorable to the event A, and S is the total outcome corresponding to the experiment E. Okay, this is the definition for the probability. This is the axiomatic definition. Now as an example we can say as an example as let's say we throw a die. Okay, now what is the probability of getting a even number? Okay, now whenever we throw a die, the total outcome is the outcome may be 1 2 3 4 5 6, any one of this may be the outcome. Now so the total outcome will be 1 2 3 4 5 6, which will be the element in the set S, which is a sample space. So number of S will be 6. Now if I have to find the probability of getting an even number, so we will take an event A, which is the event of getting an even number. Okay, even number. Okay, so we have to find P of A. Now A is the event of getting an even number. So A will contain the favorable point. Which are the favorable point? Even numbers are 2 4 6. So A will contain this element. Okay, so number of A will be 3. So by definition of probability, P of A will be favorable event of A, which are 3, and the number of total element outcome, which is 6. So the probability will be half. Okay. Now whenever you have to find a probability, always first calculate the event space. Okay, which is the sample space S. We have to calculate the sample space. Now there are many experiments when in that experiment you cannot define all the point in the sample space. Okay, but you can find the total number of element in the sample space. As an example, let's say there is a bag. So second number example, let's say there is a bag which contain 3 red ball, 4 white ball. Okay, now one ball is selected at random. What is the probability that this ball will be a red ball? Okay, so there are total 7 ball given, and 7 ball is in the bag. So the total number of outcome will be, what will be the total number of outcome? As there are 7 ball and we have to take a 1 ball randomly, so the number of choice is 7C1, which will be the total outcome. So the S content, number of S means the sample space, total number of outcome will be 7C1. We don't have to take the S in this form. We need the total number of element in the sample space. Now if we take A be the event of getting a red ball, okay, so we have to find P of A. Now we have to calculate the favorable event. Now there are total 3 red ball, 1 red ball will be selected, so total number of favorable event will be 3C1. This will be the number of element in the set A, so the probability will be 3C1 divided by 7C1. So by formula of combination 3C1, this will be 3 and this will be 7. Okay. Now if we take 2 ball from this bag, if we take 2 ball randomly from this bag, what will be the probability that two balls is white? Okay. Whenever we select 2 ball, the number of selection changes, right? So number of selection will be 7C2. If we select 2 ball, two balls from this bag, so number of selection will be number of selection 7C2. So this will be the total number of outcome corresponding to the experiment of selecting 2 balls. So this will be the S, if S is the event space, so number of S will be 7C2. Now if we have to find that the 2 balls is white. Okay, so we will select an event A be the event that selected balls are white. Okay, so we have to find P of A. So P of A means number of A divided by number of S, and number of A means the total number of outcome favorable to the event. So favorable to the event means we have to select 2 white ball. Now there are 4 white ball given, we have to select 2 white ball. So how many ways we can select 4 white balls out of 2 white balls out of 4 white balls? So this will be 4C2 divided by number of element in the set S, which is 7C2. So this will be the required probability. Okay, and so calculate it as 4C2 means 4 into 3 divided by 2 into 1 whole divided by 7C2 means 7 into 6 divided by 2 into 1. So 2 into 1 will be out 4 into 3 divided by 7 into 6. You can also calculate it by using the calculator. Okay, there is an option to calculate the formula 4C2 or 7C2. So this will be 7 to 2, that is 2 by 7. Okay. So this is an example also. Let's take another example. The experiment find the probability of getting a total 8 of throwing two dice simultaneously. Okay, so the example is find the probability of getting a total of 8 by of throwing two dice simultaneously. Okay, throwing two dice. So first we have to find the total number of outcome. So if I throw two die simultaneously, the outcome will be, so first die can have 1 and second die we can have second die from the second die 1. So 1 1 will be an event. Also first die 1, second die 2. This will be also an event. Also first die 1, second die 3. This will be also the event. So S will contain, the sample space will contain this kind of events. Okay, so this kind of outcome 1 1 1 2 1 3, first die 1, second die 4, up to first die 2, second die 1, first die 2, second die 2. In this way we will get up to 6 6. So total number of outcome will be, if we calculate this this events, we will get the total number of outcome, that is n of s, will be 36. Okay, as the first die can have total 6 outcome. Okay, 1 2 3 4 5 6. In each of these 6 outcome, second die also get 6 outcome. So total number will be 6 into 6. Okay, which is the 36. Okay, now we have to calculate the event. We have to take an event to find the probability of getting a total 8. So we will take an event A, be the event of getting a total 8. Okay, getting a total 8 means the numbers given by the dice, the sum of the numbers given by the two dice will be 8. Okay, so how many outcomes will be there favorable to the event A? So A will contain, let's check the first 6. If first die is 1, there will be no point in the second die for which the sum will be 8, right? So when first die is 1, there is no point. When first die gives 2, there is an event. When second dice gives 6, the total will be 8. In same way, if first die is 3, the second die will be 5. This will be an event also. If first die is 4, second die is 4. This will be also an event. If first die 5, second die is 3. This will also an event. And the first die is 6, second die is 2. Okay, so we will get total is 6 and total 8. So there is, in this 36 outcome, these are the favorable outcome corresponding to the event A. So number of A will be 1 2 3 4 5. So n of S, P of A, probability of getting A is n of A divided by n of S, which is 5 by 36. Okay, so if we count the total number of outcome and favorable outcome, we can easily find the probability of a simple event or composite event. Okay, so I will be giving 2 example to solve by, you have to solve it by yourself. I will be give the solution in the next class. Okay, that's it for today. In the next class, I will explain the probability in the event A and B, composite event, compound event, and how 2 event can connect it. A or B event in the same experiment will be connected, and the formula of the corresponding parts. Okay. That's it for today.